Hey everybody, so let's take a brief look here at practicing a couple of these problems where you are asked to predict your reaction type and do some balancing. Alright, so let's go to the first one. Alright, so what kind of equation should we use? Let's go with aluminum plus oxygen yields. So where on this table here is the one that you should be looking at. It's in the notes for the unit. And as I look at this, I see, well, there's a single thing. So there's an A plus B. Remember, oxygen is one of those Brinkelhoffs, the bromine, iodine, nitrogen, chlorine, oxygen, hydrogen, fluorine, or hydrogen, oxygen, fluorine, whatever, where they exist as diatomic molecules. So I'm looking for a pattern where I see an A plus a B, just a couple of things on the left-hand side, and what kind of reaction type would that be? Well, it looks here like a synthesis reaction. A plus B is going to go to C, or A plus B is going to go to AB, which is you're combining them together. Okay, so let's take a look at how we would do this. So obviously I'm going to be combining aluminum and oxygen. So the first step is to find your pattern and determine that this is a synthesis. Okay, so let's go ahead and go to the next one. Alright, so I'm going to have to make a compound with aluminum and oxygen. Well, aluminum, based on this pattern here, remember, you had family and charge. 1, 2, 13, and then it's 14, 15, 16, 17, 18, 14, 15, 16, 17, 18, plus 1, plus 2, plus 3, we'll say plus 4, minus 3, minus 2, minus 1, and 0. And if you were going to look at aluminum, aluminum is right here in family 13. And oxygen is right here in family 16. So we know that aluminum must be plus 3 and oxygen must be minus 2. Well, based on what we learned, the charge of one becomes the subscript of the other. We bring that down and we have Al, aluminum, sub 2, oxygen, sub 3. Can this be reduced to 2 and 3? No. So this is the compound, aluminum oxide. Alright, so if I want to make a compound, if I want to finish the chemical reaction, Al plus O2 goes to Al2O3. So that's my synthesis reaction. Let's rewrite it. Al plus O2 yields Al2O3. Reactants, products. I only have 2 of each, aluminum and oxygen, aluminum and oxygen. How many aluminums on the left? 1. How many on the right? 2. How many oxygens on the left? 2. How many on the right? 3. Well, let's start making some changes. Alright, if I modify and I put a 2 in front of this aluminum, then I'm going to have, cross that out, now I have 2 and the aluminums look good, but I still have a problem with my oxygens. I think I see what I'm going to have to do here. The least common multiple of 2 and 3 is 6, so it looks like I'm going to have to do something like this, where I'm going to have to do 2 times this whole thing, alright, and what's that going to do? That's going to change everything here. That's going to make it 2 times 2 aluminums is 4, and 2 times 3 oxygens is 6. And if I look over here, the way I'll have to change this is say, aha, I'll get my eraser here. I'm going to erase that one that I put in front of aluminum, say that 2 is not going to work now. I have to do something else. So it looks like to make 4 aluminums, I have to put a 4 here. And now I have 4 aluminums. And then I'm going to have to make 6 oxygen. Well, looks like if I put a 3 here, now I have 6 oxygen. So the balanced equation for this then becomes 4 aluminums plus 3 oxygen molecules yields 2 molecules of aluminum oxide. All right, and so that's the basic idea for going through the stepwise procedure of determining your reaction type and then setting up your equation, all right, figuring out what the product is, and then doing your reactants and products and balancing the reactions with the coefficients. Remember, we only can add coefficients. This is a coefficient. This is a coefficient. We can never modify subscripts. And subscripts, I'm going to circle in green here. Subscripts you can never change. Okay, you can only have modifications with coefficients that go in front of the molecular species. All right? All right, I hope that helps.